This talk was initially supposed to be in the beginning of the conference, so basically enjoy the very light talk by the end of the conference. Hopefully you are a bit tired and will enjoy it being a bit lighter than average talks of this conference. I'm Ervin, and from one side I have a huge beliefs in power of community, and from other side I always had some curiosity about the security, and that led me into the Pactum, which is very untraditional startup because it works only with largest companies in the world. We do negotiations automation, and no one else did that before us. And security challenges are needing to be combined together with very rapidly growing startup, and that was a very interesting situation to live in. However, today my talk will be a bit simpler. You can think of it as a homework for you to check some things in your code, in your production, or maybe at your friend's production environment. I will talk a bit about the authentication. Basically, authentication part is telling who is there, and authorization part is checking what that person or service can actually do. I will not touch much about authorization because it really depends, like the classical thing. What your application has in terms of roles, what they can do, it's very business specific and not some global chat. But authentication, like identifying who's there actually, is pretty common problem. Every startup has it, every web service has it, and every service in your local network also has this problem. Basically, you have two actors who need to talk to each other, and they need some trust established. First, I would like to remind some concepts, like very basic concepts of identity and access management, and I'm using Google Cloud as example in this talk. However, there are representatives of other clouds in this hall and in this room, so you can ask them if there is something that you would like to implement in our cloud. First thing, principle. That is basically definition of who is doing something. It can be a Google account, it can be Google group, it can be a Google Workspace account, cloud identity domain, which is basically free version of Google account not having a Gmail or Drive provisioning space. It can be something special like all users or all authenticated users, and it also can be a group. The interesting thing with Google Groups that you can add machine accounts in there, and you also can go quite deep with Google Groups by adding one group into another and combining a lot of identities into one single name. Role. There are some standard roles in Google Cloud, the owner, editor, viewer, but they are kind of deprecated and discouraged to use because they are having too many permissions. They're covering entire project at once, and it's much better to use at least some job-specific roles like compute load balancer admin or artifact registry writer. And even better, if you have time, you can do very granular custom roles that give you only permissions that are really needed by your software or your engineers. And it allows you to have least privilege principle fulfilled, but it will take you some time to manage the roles, add new permissions as they are added, or remove ones that are not used anymore. And the last piece of the puzzle is policy. Basically, the policy is just definition of what principle has what permissions on what resource. In Google Cloud, as Asko already explained us yesterday, every resource belongs to project, and projects can have a hierarchy. On the top you have, or not have, an organization, which is basically, in simple terms, the company domain and like global administrator of everything owned by that domain. And inside you have projects, maybe team-specific or service-specific projects. Projects can have different billing accounts, etc. And what's important in my talk is that the roles are inherited always from top to bottom. And in Google Cloud, you can define allow policies or you can define deny policies. For example, if I say that Karel is database administrator on production project level, I can later define policy that says that this billing database is not accessible to Karel at all. And Google Cloud, when it tries to determine if person has permission on resource or not, it will first go up the tree from top to bottom and to see if I on any place did deny Karel the role, and then it will do second pass and check if I somehow granted Karel the role. And in many accesses, you can use the cloud provider identity management policies to gate access to your application, because something that is serving traffic from your site is actually also a resource in the Google Cloud. And for example, there are free services, products that support that natively out of the box. These are the app engine, somewhat like Heroku basically serves your code in the cloud. These are the cloud functions, simpler code blocks like lambdas, and Cloud Run, which is basically managed container that runs in the cloud for you. And all these free services can be configured to actually ask for identity. But problem with such approach is that all free services will just require the header in a specific Google formatted way to grant or not grant access to the resource. And if, for example, if you are trying to do a web page that is asking for password, you cannot do it out of the box because you first need to send the secret header from the browser to the cloud to get the first HTML, which does not work well. But it works great with machine-to-machine communication inside the cloud. And the one also drawback is that it accepts only Google Cloud credentials. However, there is a next step up from it. You can drop in the identity-aware proxy. You heard about this product already. And this is basically a drop-in service that you can put onto any backend service in front of all three resources that I mentioned, all three products. And they will show you the standard Google auth login screen that will link to your privacy policy, ask for login password, and if the user logs in with correct credentials, the access to your application will be granted or not granted. Important to understand that it's your job to firewall away all the requests so that only identity-aware proxy can do requests from your application, because other than that, there is no way to prevent requests from reaching your application. And you have to remember that it's actually all or nothing access gate, and you will deal with authorization and user permissions inside your application. However, because it's not enough to allow only Google Cloud users and Gmail users into your application, Google has an identity platform. It's a bit bigger offering. It's a bit more complex to set up than regular identity-aware proxy, which is basically just checkbox to tick on your service. But it allows you much, much more. For example, you can use any of the following providers to gate access to your Google Cloud resources. And if you take a look carefully on the first two, then it also includes all the organizations, enterprise systems, etc., because most of them will use one of the two standard protocols, OpenID Connect or SML. And interesting that Google offers also email password authentication, and you can actually opt in into having email passwordless authentication, where each time on login, user will get a new login link without any need for passwords. And I believe that this actually solves the logging in users very well. You don't need to deal with many identity providers in your application, and your application will get a unified GVT token from identity platform, and it's very nice. However, with machines, everything is not that simple. We often take different approaches for authenticating machines and users to our systems, and I have observed many times where machine-to-machine authentication is actually done via some pre-shared password. Often it's written into the code directly, and justification is that machine needs to run unattended. We can have two-factor authentication in there, but it's complicated. It requires on-call engineer to enter some secret on every startup, or you need to deal with some huge system like Vault. And the service account is actually the machine identity, unified way to represent some workload inside the given cloud provider. And how was the typical flow to authenticate machine in the past? You still can find many places where this flow is like recommended in tutorial or answered in Stack Overflow as answer to your question. Basically, you create the new service account. You use your browser to download the JSON secret key onto your machine. You upload that JSON key to application via Secret Manager, Vault, or whatever. You click around, you make sure that the application works, and you check off the checkbox. Yes, it's done, it's working. Two main problems with this approach are copy of a top secret key on your machine in browser downloads folder, and of course the fact that you never rotate that key afterwards. And basically this approach is main reason I'm doing this presentation, because in very many cases, for example, some workload was created, let's say 7 years ago, it's working perfectly. There is, for example, automation that ensures that all the packages involved are still up to date. However, there is no automated checks for architecture decisions that have been done many years ago. And maybe if in that time there was no better solution than download JSON key and upload it back, then maybe that service is still using the old flaved way. And I would like everyone here to recheck if you don't have such bad services on your systems somewhere. And also it helps to check your own downloads folder for JSON files in there. But what would be the nice approaches that we can use today instead of downloading the key? Basically, the service accounts are designed by Google to represent the machine identity. That means that Google internally already has some means to attach the identity to machine. Google needs it internally for many ways. For example, the software-defined network that cloud provider offers you, it does traffic encryption in backend. And the machine itself is using on key to decrypt part of this traffic. Or another example is that you can configure cloud firewall to accept incoming connections only from not IPs, not the machine labels, but only if they are initiated by several allow listed service accounts, which is very nice when you deal with identity-aware proxy and firewall. And it's very helpful to understand that machine identity is surely better managed by Google than by you in your front end or back end. How it's implemented is very simple. There is a special metadata server, which is basically next hop from your running workload in your internal network. It's the pre-known URL, and if you do HTTP request there with correct user agent, you will receive the short-lived token back, which you can use to authenticate to Google Cloud Services and do everything internally what you may need. And because it's supported by default by all Google official SDKs, and it's very easy to use it for your own purposes as well, I would recommend you to always stick with these short-lived tokens and never ever use long-lived key. For example, in the previous talk it was mentioned that many cloud providers do not allow you to use certificates for login, and it compromises security. However, you can use the service account short-lived token to log in into your database if there is granted permission. And that simplifies things a lot. You don't need to deal with machine, user, passwords. You just do some grants and things just work. How nice is that? Basically, as support is implemented in all the official SDKs, your software that runs on machine is already authenticated. You don't need to have any manually managed keys. And if you actually do manually managed keys, it's very likely to either decrease your security posture or increase your bill because you are managing 6-node Vault installation that deals with that single JSON key back and forth. This is a bit of technical details, how internally secure tokens are emitted by given service account using given public keys, and you can actually verify the public keys and signed tokens inside your application. So inside the application, even if you have no firewall, you can recheck if the incoming connections are valid and digitally signed. Kubernetes, special case. You have many services on single instance, and if they all have access to the same metadata server, you are basically screwed because they all get the same machine token. However, there is a solution, workload identity. If you pass the special configuration flag to Google Managed Kubernetes, it will tell metadata server to actually give different tokens to different service accounts, which are Kubernetes service accounts. So you kind of need to set up mapping between Kubernetes service accounts and Google service accounts. Again, this setup is basically a map, and it does not involve any secrets. So you can have the mapping in plain text in your Terraform. And once you enable it, the regular generic host metadata service will be not accessible from pods, and each pod will get only its own tokens as defined by your Kubernetes setup. All great inside the Google Cloud, but what if you have a third-party service that you need to authenticate? Things get tricky or not. Basically, other cloud vendors and major providers of services, they also have their system of emitting their tokens. And because security is very often standardized, you can manually verify third-party signet request against their public key. You can do software that does that, but do you really want to deal with that? It will steal your development time from solving your business goals. So simple, you configure something again at Google Cloud. There are 3 providers out of the box: Amazon, OpenID Connect, and SAML. With last 2, you can basically integrate with any provider you may want. And now, the third-party provider emits some their token to service running on their premises, and you validate this token when you receive the request. For example, let's take a look at GitHub. Very often used, very well known. The GitHub actions can get token from GitHub if they request so, and if administrator of GitHub has granted given workflow to access tokens. Such tokens will have an issuer and some claims supported. Inside the claims, you will get the GitHub action name, branch, who started it, why started it, a lot of parameters that you can later assert in Google Cloud. It will get signed by GitHub private key, which you don't have, and hopefully no one in this room has, and sent to Google. At Google side, you configure the provider, you specify who is provider, you tell Google how to fetch the public keys, and you do some mapping. You map the provider claims that he signed with his private key to which service accounts the provider may access on your behalf. For example, very common is that you have one repository, you configure one protected branch in it for having access to production service account, and some other branch of that repository can get access to your staging service account, and these service accounts have some permissions related to production or to staging. And after that, inside the GitHub Actions, you just say that you will be getting the ID token, and you use Google provided wrapper basically, or step in the action that will exchange the tokens with Google automatically for you. And behind that line, your code is already authenticated with Google Cloud using Google Cloud Service Account token. And for your application, it would be as if the GitHub would have the real Google Service Account JSON key without GitHub ever needing actual service account key. It's all done using the short-lived tokens, and I believe it's the only way to go with bringing some services across the providers. And now the reality hits us. What about the legacy case? I have some application written, I don't know, in my basement running on my old mainframe or whatever. What can I do there? I definitely need Google Service Account to talk to Google, right? Not really. You can still work around this scenario by generating private key in that third-party place and never moving away that private key from that place. Maybe you can even delegate to some hardware, I don't know, like memory, USB stick, or something that will hold secret key in motherboard protected storage, for example. And you only upload the public key to Google Cloud. And in that case, you can even, for example, configure standard public certificate with expiry date, and voila, again, you are authenticated into the Google Cloud, but you don't need to move the private part of the key around. All solved except the developers. How should we cover the development part? It's also very common practice that developers say that they need service account to do one thing or another thing, like connecting to database or something like that. And Google offers a special service account type for that. Basically, user or developer or engineer can log in with their personal credentials and get the Google Cloud special like service account like thingy that will use only that user's personal permissions in the cloud. However, it will be working great for machine-to-machine applications. So you can have workloads on your development workstation that run as you in your permissions, and all appears quite good from Google side. And one thing that in some edge cases you will need actually man in the middle, but again, you can impersonate another account to do so, and you don't need to download JSON key ever. And my takeaways from this talk is basically like homework to you, like really make sure that you, your friends, or I don't know, people you consult, they don't use downloaded JSON keys. And some final notes on notification. First of all, if you consider using cloud-provided notification and security features, you maybe will gain some development time and solve your business problems in better way. The less secrets you manage yourself, the more secure system will be, because you can prove that you actually physically don't have access to that or other secret. You need to enforce secrets expiry, no matter where you store them or how, and try to avoid moving secret from the machine it was generated on. Asko didn't mention that, I think, but in Google Cloud you can specify the organizational level policy or project policy or maybe folder policy that will actually disable the JSON downloadable key creation for that project or folder altogether. And I believe that's very good security policy that will help you a lot. And the last tip from me would be that always grant permissions to groups, not to individuals, because you can do group nesting and be as granular as you need, but still it's easier to manage. Thank you, and I believe it's time for many, many questions.
Thank Thank you on insightful talk. Do I see many questions? Okay. Let's start from here.
Thanks for such a great talk. I have a question again, just trying to understand, maybe it's a noob question, but let's say I have a service that is outside Google Cloud, right?
Yes.
And it needs to access some Google Cloud resources.
Yes.
So let's just make a simple example. It needs to write logs to Google Cloud.
Yes.
So I do need for this service that lives outside Google Cloud a service account, right?
Yes.
Yeah, but then, and let's say now the question is, how does Google know that it's actually this service is the one that is like sending me the logs? So I do generate the key, the JSON key of the service account, or not, or I want to try understand in this use case how the auth exchange should happen.
In this case, you have one of the two options. If your service that wants to write logs has a provider that can emit well-known formatted one-use token that you can assert with provider's public key in Google, you can basically say that, yes, that I have configured this provider, I will trust its public key and sign the request to get the short-lived token of this specific service account. And you can basically have some code or wrapper in that provider that will exchange the provider emitted token to the service account single-use token.
And so you would say it's an anti-pattern to generate the service account JSON key and install it on the service, because that's pretty much one more secret to have to manage. Or
yes, you should never download and create JSON key.
Okay, thank you very much.
Thank you. Moving away, we actually have a bit of a race condition here because the other room is not finished yet. So enjoy.
Okay, thank you. It's more like a troll question, but is it the same Google that you're offering that blocks people out and don't even talk to them? I mean, can you give examples of the same functionality in different clouds? Are you aware that other cloud providers also do that, right? And
I know that, for example, identity-aware proxy, after was announced by Google, was implemented at least somewhat in Amazon. However, the full cycle of having some external identity provider, maybe you can use the third-party vendor like Okta, which will be generating standard keys that is easier to assert in your application. But in case of Google, you have like Okta-like offering backed into the Google Cloud. Does it answer your question somewhat?
Yeah, sort of. But still, I mean, I'm really scared of those stories when people just get locked out from their full ecosystem because Google just, something hits its bots and they think, okay, you need to go. That's it.
You need to think through the account recovery system, like how you would recover the account of your, let's say, organization owner, for example. And very common practice is to have actually domain parked not in the Google, but in some other place like Cloudflare or maybe some Estonian provider. Because in that case, you can prove ownership of domain to Google Cloud Support by posting the DNS record that they ask you to publish a domain. And that basically will help recovery process. And another thing is that you actually supposed, well, not really supposed, but it's very wise to do so, to buy at least like minimal price support package. Because if you don't have support package, then the cloud support is related only to billing. And if you pay at least some support package, you will have customer representative who actually knows you, who can verify your identity and can expedite locked out issues, for example.
So one question on this tracking of those service account usage. So for example, on Google, is there some overview somewhere that how many requests are coming from the old legacy service account keys that have been created like 2 years ago, or
Yes.
you can see how many are
Yes,
coming from the
in
new
Google
f-
Cloud Monitoring, there is a metric per key when you use some service using that key.
Okay.
It's a bit trickier to figure out who is using, because you cannot have a, for example, log saying that this IP used this key, but you will get metrics, and actually there is also a service that tracks exact date and keys, like timestamp of each secret usage.
More questions? Okay, in this case, let's have a big round of applause for Ervin.